Alright, I got here a Sonora radio. It's an old one from in the 20s. Picked it up for $15 at an auction. It's not bad. The box is in good enough shape where we won't have to do anything to it. It's not working. No cord on it. It's got some parts left over inside of it. Speakers in there, hanging there. Okay, let's see. To get it out, I think it's only held in by the knobs, which are held in by some set screws. Okay, we'll get those out of there. These are not the original knobs. The original knobs were wood. Okay, I've got some somewhere. Okay, there. Okay, we got a piece of grill cloth here. I don't know if it's original. It looks like it's not original, but it might be. I don't know. It'll do, whatever. Okay. Now, the speaker is just hanging here. All right, this is... it's a permanent magnet speaker, so this is not original. But it's intact, completely intact, and it will work. It'll do. Okay, now. Okay, the tuning is 1-to-1, so that doesn't make any difference. Got a couple of active tubes, a rectifier, a power tube, and 2 RF. I mean, that's it. That is just, there's nothing to it. It's got RF, power tube, and a rectifier. That's it. There's nothing to it. Good grief. Okay, the volume control, 15. So it's the old-fashioned antenna shunt type of volume control. All right, what's it look like underneath? A mess. Okay, somebody has sort of gone into it. Okay, we're missing a power transformer. Okay, that's probably why I got it for $15. Somebody else saw that the power transformer was gone. So it's 167 volts. It's a low voltage power transformer. And it looks like a 3-inch core. Let's see. Yeah, it's a 3-inch core. So I'll go find a transformer that'll work that has a 3-inch core. Anything will work. It's not critical at all. All right. Boy, it's not really. What a mess. Okay, after looking through all the stuff out in the garage, I found a transformer here that is going to work just fine. It's a little bit different voltage than the original, but it's close enough to where there should be no problem at all. The original had 160 volts. They said 167 volts. This one's 250, so it'll be a little bit more B+, but that will make the radio work better, if anything. Okay. The main thing is it's the right size to fit in here. Oh, how the heck? Why it would burn out? A radio like this, it had to be the filter condenser shorted. No doubt the reason I got this radio for $15 is because somebody noticed it was missing a power transformer, and they didn't have a bunch of power transformers out in the garage like I do. I got about 200 power transformers out in the garage, and maybe 3 or 4 that would work just fine in this radio. But this right here is probably what took out that transformer. Let me get rid of the hose here and see what that thing reads. Oh my gosh. Oh, it just reads 0. Just 0. I don't know. I don't know. I think, oh, I see what happened. I see what took out the transformer. I see what took out the transformer. The tube socket, if you look here, this is the filament right here, and these are the high voltage. You can see an arc from the high voltage to the filament on that tube socket. That arced and shorted out the transformer. Okay. All right, I got to get a tube socket. Okay. Now, we'll have to go find another socket that has that spacing. See it there? Direct short. Wow, that's terrible. All right. Got a brand new one here. It's never been used before. Has the same hole spacing, so it'll fit right in there without any grinding or fooling around. Okie dokie. Okay. That's brand new. Okay, now, let's see. Okay. Wait a minute. Oh crap. What a goose. When I put the shell back on there, one of the high voltage wires is twisted down inside there. Oh, what a dork. Okay. I was going to say, there's only 2 high voltage wires. Where's the center tap? And, you know, if the center tap was shoved in there, it probably should touching the shell, but it isn't the center tap that's down in there, so I can't leave it. If it was touching the shell, it would ground out and be okay, but the damn thing is one of the high voltage leads, so I have to take it apart again. See, a damn thing is sticking down inside here. Ah. Okay. Okay, now, let's see. Get through the hole. Okay. I'm wondering why that fit so tight. Okay. There we go. Hell to do. Okay. Okay. All right, now, just like these. Okay. It wasn't hardened yet. Okay. Okay, that takes care of the 80 wired up. Okay, next. Okay, now the next thing I need two. Okay, these were sitting right here. Okay, we don't have that in there anymore. That goes in the junk. I'm going to save these old condensers. I like these old condensers because the cardboard box is good. The insides of them are no good at all, but the cardboard boxes are very good. Okay, 33 at 400, that'll do. Okay, I got a 10 at 400. Now, the thing is, the 10 would fit inside here. The 33, it would fit in there too. Okay, all right, here's what we're going to do. See, I'm going to take that and cut it. Do it without cutting my finger off. Okay, fold it open. And I think I can get, we'll get this here. Okay, now what I want is to pull. Okay. Okay. See, that's a piece of shit right there. Okay, now we got the box. Okay, and I gotta bend that down, and it's definitely gonna mark it. We do it backwards, and woo, we could have a bang. Okay. Okay, and now I gotta tin those terminals up. That down there, I'm just going to go around it. All right. Okay. That'll be one of our filters. Okay. 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 Okay, we have the plus to plus, okay? See, and then I put it in there. Already. Okay, that looks good. Okay, now where's that thing? Okay, I need another one that's about 2 inches long. Number 8 by 2 inches. Gets our capacitor holder in there. Now these, I'm going to put them both in there. Now this is the, let's see, which one? Okay, this one is the 33. I'm going to put it on the back. Okay. And I'll put the 10 in the front. Okay. All right, that is just gorgeous. The original speaker had a field coil that was used to derive the bias for this thing. We don't have that anymore. This speaker that we're going to use is a permanent magnet speaker, which has no coil. So we're going to have to go ahead and put a resistor divider. Okay. Okay, it's pretty low. Okay, so we're going to put that same ratio. They're not putting much bias on that 47. I'm going to put, okay, probably around 20 volts of negative bias on that 47. Okay, so we're going to go from here to ground with something, and then we'll take a voltage divider across it to get our voltage for the tube. Okay, I got the speaker bolted on. Okay, that just fit right on there, and it's in good shape. Got the audio transformer mounted. Okay, now what's left is all the wiring. Okay, we have a surprise that happened. I was looking at these tubes, and it occurred to me that these might be 2.5 volt tubes. The 47 is a 2.5 volt tube, so that is a disaster, because the power transformer I have does not have a 2.5 volt winding on it. And the only other transformer I have that would fit on here that has a 2.5 volt winding would not light 3 tubes. The winding on that transformer is only rated at 1 amp. Between the 3 of those, it would be 3.5 amps. That would burn that transformer up quick. So I have to use 6 volt tubes in here. Okay, the 80 is okay. That's 5 volts, so that's okay. Now, the 6D, what I'm going to do is replace the 58 with a 6D6. Has the same pin connections, has the same function. And then the 57 is a 6C6, which is the same tube, but a 6.3 volt filament. Now, this presents a big problem. A 47 has no 6 volt equivalent that will directly plug in. The 47 is a 5-pin, big pin tube. It uses the 5-pin large socket. It's not all of the tubes that would electrically be equivalent to the 47 use a different base. So I would have to cut the tube socket out and replace it with a different tube socket. I've already done that with the 80 tube socket, and I don't feel like doing it again with that one. Now, what I did was I took a 6K6 and wired it onto a 5-pin base. So it just plugs right in there, and that will take the place of the 47. So that solves that little gotcha. Okay, the next thing that has to be done is to complete the various wirings. Now, since this this speaker has no field coil, we don't have the voltage drop of the field coil to generate our bias for the output tube. The way this tube is designed, the cathode is hooked straight to ground. I mean, it just, we don't have any bias developed on the cathode. So what we're going to have to do is we either put a cathode bias resistor in and eliminate this stuff here altogether, which we could do. So we're going to change this around completely. All right, we're going to put a resistor in here. We're going to take the center tap, go straight to ground, and okay, I was going to wire it the same as the other one, but now we're not. So we have to change this out here. Okay, that means the two pluses are now separate. Alrighty. And this is the filament. Now I think the filament center tap, I do not know which is which. I'm going to have to hook the power onto it. I don't know which. I think that's the center tap, and these two are the filament. Okay, everything is isolated. Okay, put this to AC volts. Okay. Okay. Double check. We don't have anything. Okay, turn power on. Okay. And if I measure here to here, okay, that's the 6.3 volts. So this one that has it twisted is the other. Okay. Okay. The number of people, and I can see a time when there's not going to be anybody left that can work on these old radios. Put it out of the way. Okay. Now, okay, this mess right here is the bias network that they had in there. Okay, that is no longer being used. So we take that out. We have a capacitor in here that's been changed. So I'm going to go ahead and measure that now and see if it is good. It is good. It's over 20 megs. Okay, that's going to be a piece of junk. Oh, no, it's good. Megohms. Okay, that's the one that absorbs the spikes. Cathode is going to be on that one, so I have to go from there to ground. Okay, the screen is down there, so I'm just going to bend that down and solder it on there. Now, the plate, okay, we got to have two wires that go up to the front. Okay, I've got to find some wires that have to go up through here to the audio transformer. Some wire here to run up to the audio transformer. Put to there. All right. Boot. Oh, don't want to ruin it. Okay. Oh, here comes a customer. Are you a hungry kitty? Oh, she's a hungry kitty. it's din-din time, and we didn't have any din-din yet for Kitty. Well, we'll just have to fix you some din-din. Yes, baby. Yes, we're going to fix you din-din right now. Okay. Put solder on here first. Very good. All right. Here. Okay. Okay. Now, that hooks B plus onto the entire radio. It goes to all the places over here where the B plus goes. Okay, that's good. Now, this wire goes through this hole up to the audio transformer. Okay. Okay. And there we go. Okay. All right, and that one there also goes. Okie doke. See, that takes care of B plus and the plate. Okay, now these are wires that have to go to here. Okay, I'm going to bend those around. All right, that takes care of wiring in the speaker. All right, these two are the filament. All right, the other filament goes to the other one. Okay, I'm just going to trim a little bit off of there. All right, I need a 470 ohm. I'm not going to use this 2 watt. I don't need a 2 watt in there. I'd rather have a 1 watt. This looks like it. Okay, 500 ohms. Okay. Okay, this is going to do perfect. Okie doke. So that will just barely fit. Oh yeah. Okay. right. Across that, we need a about a 25 microfarad capacitor. Let me see what we got here. 25 at 50 volts. That will do just fine. Now we got another one here. This is our grid resistor. It has to go to ground. All right, that gets our audio amp done. The next thing to do, we have to get over here, this mess. Okay, wow. All right, let me pull. I want to see that these are good. Okay, put the meter on the highest scale. This is on the 20 meg scale. We can measure 20 meg ohms. And the capacitor. Past 20 meg ohms. Okay. These are going to be good capacitors. Okay. Somebody's replaced those. Those are not original. The original ones were a different style. Okay, this one here looks like it goes to the B+. This is the B+ wire that goes from here over to the B+. So let me make a quick ohm test to make sure that that is what it is. Okay. That's going to go to pin 2. No. That ain't going there. What? Okay, so this is the B+ right here. Okay, so we take that and go to B+. I am not seeing, we've got to have the wire from that plate straight to B+. So from B+, okay. All right, that's there. But I don't see pin 2. 2 to power supply. We don't have pin 2 making it to the power supply. Pin 2 is not making it to the power supply. Pin 2 has no connection. Okay, that one there has connection. Okay, we have got an open coil. This coil right here is open. We don't have a connection to power supply from pin 2 on that tube. Good grief. Don't see any broken wires. Okay. All right. Okay, that one there we've got. The other one goes here. It ain't there. Ah! Okay. This coil on here is open circuit. It's just so classic, my God. I've got to get to a nut that's back down under, behind everything. All right. Oh, that wasn't too hard. Okay, here is the culprit. Okay, if we look inside, there's the coil that's bad. This is crazy. Okay. One. Not go the other way. Okay. I just don't see how it can be bad. But it sure as hell is. It's got no connection. It's got no connection at all. It is definitely screwed. Okay, I'm going to start pulling wire. Ah! Whoa! Look at that. The first turn. Okay. All right. Let's see if we lucked out. It might have been that first turn. Oh, of course not. All right, let's keep going. It's got something. There we go. The wire's just falling apart. Look at that. It's going to be right in the top layer. No, it's not. No, it's not. Well, I could have cut the wire. All right, I got to get more wire off of there. See, we can cut as much as maybe 10% of that coil off of there without hurting it. If we can find the break in 10%, we'll just go from there. It'll be okay. So I'm just going to start pulling wire. Maybe we pulled maybe 10 or 15 turns off of there. That's not even close to 10%. But have we found the break? I'm not touching over here. That's it. Okay. Okay, we pulled the top maybe 10 turns off of here and we got the brake. Okay, now, okay, absolutely. The screw goes back through there, and then this one goes on to this. Okay, now let me solder the connections. Okay, we got it. That one reads. That one reads. Okay, both coils are now good. Okay, next we got to put this back in here. I'm going to have to somehow, see, and I can't turn it on the bottom. I have to turn the top. Okay, what if I do it the other way? If I go under here and tighten it from the bottom. Can I get to it? All right, that's 2. Okay, now this resistor goes on the bottom along with the power supply wire, which is this one. Okay, 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 that comes from the condenser, tuning condenser. Okay, and no, this one's the tuning condenser, the other one's the coil. Okay, so this one goes here too. Well, that's not going to be fun. Okay, let me get it now. All right, I'm going to check from power supply to pin 2. We got it. Okay, that gets the coil fixed. So that gets the RF section straightened out. Good grief, this thing's had a bunch of stuff wrong with it. Okay. So the RF section's done, the audio section's done, rectifier is done, filter capacitors are done. Next, we have our input power. Now, this is a transformer set, so we always put a fuse. I'm going to get a fuse and put it in here. We don't want that transformer to blow out on somebody again. It's not likely to ever do it again, but in the new capacitors, but still, we always put a fuse because the transformer's hooked to the line. Anything to the line needs to be fused. You don't ever do a radio with something connected to the line that's not fused, or you're going to have potential for disaster. Now, for transformer fuses, you always use a slow blow fuse, a delay fuse, so that it doesn't blow on the turn-on surge. Now, I do not recommend soldering to fuses like this. I've done this 1,000 times, so I know how to do it. But you don't know how to do it, so I don't recommend it. You should use a fuse holder. The trick to soldering onto a fuse, fast, very quick. You saw how quick we were on there and off? Okay. If you leave it on there too long, it melts the fuse that holds the element, and then the fuse will go bad. I hear a meow. Oh, there's somebody that wants lunch. There's somebody that wants lunch. want lunch? You want lunch, little girl? Yeah? You want lunch? Oh, you kitty, you want some lunch. Oh, you're a hungry kitty. Yes, baby. We're going to have lunch right now. Okay. Aw. See, she's saying hi to everybody. All right, lunch. Well, I'll get you some lunch. Okay, the next thing we're going to do, we've got the fuse in there. We're going to get us a line cord. All right, we're going to use some of this old-fashioned style line cord. And got us an old-fashioned plug. Okay, let's see. All right, now to keep this from fraying, we'll use some of this stuff. That's neat stuff. It's called Bondit. Expensive. This stuff, this little thing here costs 10 bucks. It's got just a little few drops in there. The difference between this and super glue is that we can harden this instantly. All we do is turn this little light on and it hardens up. Okay. Hi there, sweetheart. There's my kitty. She just got through having her lunch now. Okay, see, it's hard as a rock. Okay, and I can just trim. What? You want to come up here and say hi? Come here, baby. Oh, you kitty. Come here, sweetie. Here. Here. Say hi to everybody. Okay? Huh? Look into the camera and say hi. All right. That's right or not. That's good. Good enough. Okay. You can sit in my lap if you want to, okay? All right. Okay. See, now that makes that hard as a rock so it won't unravel. You can do the same thing with ordinary super glue, but it just takes a little bit longer to harden. And you tend to get it on your fingers. Okay? Okay, now that's a little bit crummy looking. The blades need to be a little bit shiny here so they don't get bad contact. It has to go all the way over to the power switches over here. Okay, so that has to go through there and up to there, so we're going to put the knot right here. That's there. Okay, that'll go through and up to it. Okay, that's going to do it. Yeah. Okay, now that can't be pulled out of there. Okay, next. This is some good stuff here. It's used on audio leads, so I save it. Okay. Now, I need a piece of shrink tubing to go over that. And remember, when you're soldering the fuses, be quick. Okay. Very, very quick so we don't melt the fuse. Over there. Okay, and I'm just going to, a little bit there, a little bit there. Just enough to where it can't move off of there. Okay. Now, that gets our 120 volt wiring taken care of. Okay, if I go to here with the meter, okay, if I turn it on, off, we see it. Okay, now that takes care of that. I've got one other thing here that I think is missing. We've got a pilot light here. Okay. Okay, it's hooked up okay. No problem at all. Okay, the antenna is going to go to right there. That's the antenna connection. So that's the antenna terminal. I have to find some wire to use as an antenna. We'll take the antenna wire. Okay, there's a little hole right here that I can go through. I'll take it and tie a knot in it. See, we don't want to be able to jerk it and break the coil. Okay, I'm going to have to go in the attic and get an 80. I don't have a, I haven't got a rectifier tube down here. All right, got us our 80. Okay. Okay. Hey, the radio is finished. At least the rewiring part of it is. Okay, let me get this around here. All right, let's see what happens. Okay, it's lit. Okay, 28 watts, not bad. Okay, tube's lit. Uh-oh. Okay, it's got to be lit because I hear something. We're not getting diddly squat out of it. Yeah, it's lit. It's lit up. Okay. We may need a little bit more. We shouldn't need much of an antenna here in Houston. Stations are so damn strong. 1000 volt scale. Ground. 250 volt scale. Okay. 250. Okay. We're measuring 175 volts, which is very close to what they show on the schematic. Okay, in a 50 volt scale, we're getting about 18 volts. 17 is what it shows in the book, so that's correct. All right, if I go onto the 6C6 with a signal generator, we should get some noise. Okay, what we'll do, we'll try putting a signal generator into the 6C6 and see what we get. Okay, I suspect I have a wiring error. Okay, so what I suspect, all right, I'm going to go ahead and connect the generator. Where's the generator? That is absolutely disgusting. We should have screaming voltage on there. I think I've got the cathode to the wrong pin. I think the cathode has to go to the other one. I don't know if it's going to reach. I'm going to hook onto here. Okay, and go to the other pin. Okay, now, power. Oh, wire came off. Oh, for heaven's sakes, more wires. The tube isn't lit up. I can't see anything. The filament wire from the transformer. Okay, power. Okay, that's better. 34 watts. Okay, we've got hundreds of volts. Okay, first thing I got to do is get this connected to the other pin. That means I got to extend it. Okay, now, first thing I'm going to do, I'm going to connect the generator onto the speaker and see that we get signal. Okay. Oh, crap. The speaker's a piece of shit. What next? What next? God, it looks so beautiful, but the damn thing has got no signal. Damn thing's got ohms. But we're sure as hell not getting crap out of it when we put a generator on it. I don't know. Oh my gosh. Oh my gosh. I know what it is. This used to be a dynamic speaker and the coil was burned out. They took the coil out. So there's no magnet. There's nothing. They took the, oh my God. Oh, you talk about another, oh shit moment. What it was, this was a dynamic speaker, had a field coil. The field coil was burned out, so they took the coil out and they didn't put anything back in there. So it's just a piece of steel in there. There's no magnetic field. Oh, for heaven's sakes, what next? Oh, this radio it's not worth all this work. It's not worth all this work. Oh my God. I can't believe this. Oh my gosh, it's hilarious. It's got such a nice cone. I don't like to just dispose of it because it has a good cone. It's so hard to find these speakers that have good cones. See, it had a coil. Oh shit! Isn't that enough to just make you want to... Oh yeah! Oh my goodness gravy. Unbelievable. Oh, for heaven's sakes. Okay, first thing I'm going to do, I'm going to go up in the attic and see what I've got. Speakers this size. Do I have another speaker this size? Good grief, no wonder they threw this damn radio away. All right, up in the attic, find a speaker. I might have one. All right, I got another speaker. I have one upstairs that has a magnet. Boy, this radio has really been a winner. I just throw it in the trash and hell with it. Okay, now. Okay. Okay. Ooh, that's good.
Mandar a volar las pelotas correa, cuidado. Una buena situación para Correa, viene después.
It works. Oh, well.
12, 18 hours.
Yes, please. Where do I sign?
I don't know.
He peleado la buena batalla. La verdadera batalla no está aquí en la tierra, está en los aires. Ahí es donde opera Radio Aleluya. Efesios nos lo aclara. Que la guerra es contra principados, no soldados.
That's it. The damn thing works. Okay. Now, we've got to get it back in the cabinet. Got to see what the next oh crap moment is on it. The box looks beautiful. There's nothing wrong with the box at all. It is completely satisfactory the way it is. We don't have to do any work on the finish. Shit. What a nightmare. Okay. Oh, that's no good. That's no good. Okay, we got to put that. Okay, let's see. That goes. Okay, I'm going to go out in the garage and just spray some. You can't win. guy. You can't win. Did you see what I just damn did? I put the corner of the box through that damn speaker cone. I just punched a hole in it, damn it. Oh. You can't win. Oh. Okay, I've sprayed that with contact cement. Got to get this in there before it dries. Press that down on there. Okay, that looks good. Okie doke. That'll do it. Yeah. I can't win. I just can't win. That was a perfect cone. And then I go and stick the damn corner of the box through it. It just absolutely, it's enough to make me just scream. Okay, this is just contact cement. The good stuff, not the water-based crap. Okay. I'm just going to go around. Make it last for the rest of history. See, this stuff does not turn hard. You don't want to use any kind of glue that turns hard on the cone. You want this flexible rubber so the cone can wiggle. It has to be able to vibrate completely freely, or else you'll lose your low frequencies. You sound like an old-fashioned telephone. But this stuff here stays rubbery after it's hard. Glues the paper together, glues all the fibers of the paper together so that it'll never wear out, yet stays flexible. Now the only thing that'll liquefy this is this brake cleaner. Brake clean the stuff in the red can. It's a dry cleaning fluid. You just take it and spray a little on that thing, and it just liquefies that glue. That lets you use the brush more than once. You can always go to the dollar store and get you a package of kids' paint brushes. They're little wood paint brushes. This is one right here. It's you get like 5 for $1 or something like that. They're little bitty paint brushes, and you just throw them away after you get through using them. Use it once and throw it away. 20 cents a piece. It doesn't matter. But you can clean it off if you're using good brushes like that one. This one's an expensive brush. This was like $1.50 or so over at the art store. Okay. Now that gets rid of the problem with a ripped cone. Dadgummit. Okay, now let me look at the bottom. What do I need? I've got to see what I have to have. See, I got to have something that'll thread in there. It looks like a number 8. Okay, they're number 8 screws. Okay. Let's see. Another one there. All right. The last one. Okay. That looks good. Okay. That's it. Okay, it's in the cabinet. It's in the cabinet. Okay. Now, the knobs that came with it, these are not the correct knobs right here. These are more modern knobs, so I'm going to find some knobs that are more appropriate. Some of these knobs are extremely hard to find, and if I came across a radio that needed one, it would be disaster if I used it on a cheap radio like this. Okay. Okay, that one will go on there just fine. It needs to be a wood knob like that. Okay, I'm going to go out there. It'll take me 15-20 minutes to machine another one of these. I will machine it on the lathe. Okay, there it is. It's not a bad looking radio. I got to take it open again. There's the tuning condenser plates are scraping together. I'll have to take it open again, straighten them out. Ah!